Hello everyone, my name is Taha Zubair and I'm from Bilkent University. In this video I intend to show you my EEE 102 project. My project is basically a scoring system for a mini hockey game. As you can see, this is going to be where I'll display my scoring system. I'm going to display the scores on the 7-segment display of the basis. So this is where I'll be showing my scores. I have a switch which turns the display on, and this is the switch, so now the display is on. Now to show you how the scores change when I score a goal. As you can see, I have scored a goal and the score has changed to 1-0 for the away team. Now let us score a goal for the opposite side. The score for the opposite side has also increased. So basically I have used brake beam IR sensors, which give an output of 0 when there's an object passing in front of them, and so I've used them to show whether there's a goal happening or not. So now we can see that the score is 1-1. What I want to display is what happens when a team scores 10 goals. So let me make the away team score 10 goals. Score is 9. As we can see now, if I score one more goal, Team A should win according to my code, and let's make that happen. So now as you can see, it displays A, which means Team A has won. The same happens for the opposite side, but now let me show you my schematic for the code. As you can see, this is my code. I'm taking a clock input which is being divided into 0.5 Hertz, which I'm using for the decoders 3 and 4. This is so that the score changes every 2 seconds. I'm checking for the score every 2 seconds basically, and I'm also dividing the clock into 1000 Hertz. That I'm using for my multiplexer, which decides which anode of the 7-segment is going to be working. That you can see is here. This is my multiplexer. Other than that, I have these decoders, decoder 3 and 4, which basically take the input from the sensors and change them to 4-bit digits, which is basically the score. This 4-bit digit then goes into the decoders 1 and 2. These decoders change this 4-bit score into the 7-bit value, which can then be displayed on the cathodes of the 7-segment display. This then goes into the multiplexer, and then from the multiplexer we have two outputs, the anode and the cathode, which can be seen here. Okay, so the problem I face with this project is that the output of the IR sensors is not ideal. This means that if something passes in front of them, there's not only one falling edge, so there's like 3 or 4. So if I connect that output directly to my 7-segment, then the score increases by 3 or 4 every time the puck passes, which is what I don't need. So to fix that, what I did was I stored this output that increased by 3 or 4 inside a signal within my code. And once it was stored in a signal, I checked whether that signal was greater than 0 or not, and if it was greater than 0, then I changed the score by 1 only. Otherwise I didn't change the score. When the score changed by 0, I reset the score to 0, reset the signal to 0 so that the score can change the next time as well. For this I used a clock of 0.5 megahertz, so the scores are checked every 1 second, every 2 seconds. So this was my project, the scoring system for a mini hockey game. I hope you liked my video. Thanks for watching.